I want to do the physics first, yeah. Coulombs law.
Who's this guy?
Who's Coulombs?
No, the picture in Google.
Oh, I don't know.
Just scroll up to say his name.
He looks French. Victor Hugo. You know Victor Hugo?
Is it Hugo, the guy who made the ratchet for the clock?
I don't know. I don't know if it's that guy. If he did that, he was an author.
Friends.
Yeah, well, author too. Writes dramas and novels and things. But I don't know if he would have written anything that you know. Has that loaded? No, it hasn't. Can you press the button? Yeah. Okay. No, sorry. Victor Hugo, I think, is way too cultured for you guys. Sorry.
You can drink Pepsi at any time of the day.
The people who drink Pepsi don't know about Victor Hugo. It's a class thing. Right. Let's have a look now at the physics here. We're looking at the physics first, the questions from yesterday. Okay, first one. 2 electrons are 0.009 nanometers from 4 protons. The electrons will be... What the heck? Yeah, okay, so what's the force between basically 4 protons and 2 electrons? Oh.
It's off. Now it's on.
Is this... What's wrong with this hunk of junk?
We have lots of free lessons today because no EAP and no chemistry. So if you want to take any.
Yes. Yes, I do.
Next week, I think we have it.
Do we?
On Monday, I think we have 4
Extra classes.
That's funny because nobody told me this. So nice. This is a nice way to find out. It's like the principal's like, you can find out from the students. Screw 'em. Right. This one here we have 4 protons and 2 electrons. So I think this one is fine. F equals K, and it's 2e 4e over, and the distance is 0.09 nano squared. That's all easy peasy. Do you have an answer here, or could you put it in your calculator, please? 8.99 times 10 to the 9 times 8 times e squared over 8.09 times 10 to the minus 9 squared. Huh?
No.
Sorry, 0.09, thank you.
2.28 times 10 power negative 9.
Are you sure? Say again?
2.28 to the negative 9.
Now, it's not that I don't trust you, but I don't trust you. Does anyone else have this answer? Yusuf, did you get this answer?
100 at the same answer.
No. To the minus 7, yeah.
I just can't trust you anymore. You're destroying the trust between us. What is it?
Why is it?
2.28
Okay, I
times 10
missed
to the
the
minus
zero.
7. Yeah.
I'm just 1 power behind.
Yeah. And this is why bridges collapse, you know? Okay. Number 2. An electron is orbiting 2 protons. What is the velocity? Okay, so here we have 2 protons, an electron, and we have a distance here of 10 to the minus 10. What's the velocity? Well, you know, it's a circular motion. So V equals omega r. You also know F equals m omega squared r. So that means V will equal F over m or square root or, because I can get the omega from this. But the f we don't know. We can get it as using k q1 q2 over or squared over m or times or. Now, won't make the same mistake as yesterday. So what I can do is that makes that a cubed, and that can come up there. So I'm left with square root k q1 q2 over m or cubed times or. So now I have the velocity in terms of q's, mass and radius, all things that I know. Yeah? So what we need to type in on the calculator is 10 to the minus 10 square root mass of the electron 10 to the minus 30, because it's cubed, 8.99 times 10 to the 9 times e cubed. Okay, Yusuf and Andrew, please. Feel better now?
Yes.
Huh? Is it m squared? No, what happened was I moved that m up to there.
Can you do
No. What I mean is, this m was down here, and I just moved it up to here. It was or squared from the f. But you divide by another or, and that's why it becomes or cubed.
Okay, the answer is...
You're not happy? What's the answer?
6.4 times 10 to the negative 4.
Yeah?
question?
1 sec. 640 micrometers per second. Yeah?
F equals k q1 q2 over r squared.
Yeah.
Where did the m come from? The one on the numerator.
The original m?
No,
This m?
this m.
That's this m.
Why do you have it written twice?
Oh my goodness, that what Lee was asking me. I just took the m out here and moved it up there.
Okay.
Okay, people don't listen to me.
And the r stays down and then you move it up again and then it becomes cubed.
What? Right, can we go on to the next one now? Good? Yep. This is quite common in the exam because these motions are circular motions. Don't be surprised to have that topic mixed in with this topic. It will be appropriate to have them mixed like this. Okay? Right, what's the next one all about? An electron is trapped in an orbit around a proton. How much energy is required to free it? Yeah. Yeah, it's just the PE equation. So PE equals minus, what is it, QK, Q1, Q2 over R, not R squared. So that would be minus 8.99 times 10 to the 9 over 10 to the minus 20 times E squared. It is 10 to the, yeah. Okay, what's that, please? Oh, and this is a little trick. How do you change it into electron volts?
Times 1.6.
No, the other one. Divided by E. So if you divide your answer by E, that's like not having one of these E's to begin with. So if you just don't have the E on your calculator when you type it in, then we have the answer in electron volts automatically.
Just have one E.
Yeah, just have one E. What did you get?
minus 2.3 times 10 to the negative 8.
No? You disagree?
Yes.
That's a minus 20 now, you know.
I will check it.
You got this?
Did you include an E? Here, I can see it's a square for me.
Yeah, don't have the
Only
square.
E without the square. So it's minus 1.44
Yeah?
times 10 to the 11, yeah. So times 10 to the power of 11.
That is big, but not outrageously big.
That's what I wrote.
Yeah. Not 6 is mega, 9 is giga. So this would be minus 144 giga electron volts. That's how much energy you need to ionize this electron. Yeah. Do you do any sort of ionization energy? Like, I mean, you know what ionization is in chemistry, but do you discuss the energy required to ionize?
No, we get values and we...
Values of what?
The energy.
In what units?
Kilojoules.
Kilojoules?
Yeah.
Outrageous.
Kilojoules per mole or something.
Kilojoules per mole?
Just kilojoules.
Kilojoules?
Just kilojoules.
Just kilojoules.
Energy can't be per mole.
Wait.
I mean, of course you can.
Yeah.
It's just energy.
Bonds, remember?
Yeah.
CC bonds. That's
But you know, you could do, for example, if you had coal, you could say the energy per mole of coal.
Okay.
If you want to be technical about it. Right, can we look at the fourth one now? At the end of season 1 of Flash,
Yeah.
you remember the vortex?
Yeah.
Yeah.
Guys.
People stop saying that, please. I could be talking about anything.
Does he
Be quiet, be quiet. Silence you. At the end of season 1.
person? He did this, I was like, oh.
Why are you
It's the thing.
No. Here, at the end of season 1, there was the vortex.
Yeah.
Do you remember?
Yeah.
And it's kind of funny because it's an example of when people use units, but maybe don't really know what they're saying. So they're saying, oh, that vortex has so much energy in it. You'll have to run so fast. It has like 10 giga electron volts in it. You know, it's like, well, that sounds big, giga electron volts. We're like, wait a second. That's like the amount of energy to ionize an electron. That's really not a lot of energy. So giga.
People don't even understand, so it doesn't matter.
No, I know, but still, you know, like when you're watching it and you're going, that.
Only you can do this.
Right. It'd be much more appropriate to say gigajoules than giga electron
What
volts.
is this vortex?
You watch the flash and do.
What's the spelling?
A vortex?
V-O-R-T-E-X.
Yes, yeah.
Okay.
Why is the cube?
The series called Flash.
Yes.
Why did
The-
you manage?
No, I don't actually know if it is called Death Flash because there was a 1990s version.
No, it is called Flash.
The new one's called
Pretty
Death
sure it's
Flash.
not this one.
Aye. Right, 4.
Oh, this thing is cool.
A proton is fired at speed v towards 3 protons. Oh man, screwed up the English big time. As the electron approaches. We speak English, good time. Right. What is the value of V if the closest the proton gets to the protons is protons is? I don't even have the grammar. It's like every grammar mistake you could make in the last question. I got the is, I got the an. Right. Sorry guys, I totally screwed up the last question's English. Yes, totally. So what I meant to say was you have 3 protons here and 1 proton here, and this is fired with V towards this one. Yeah? Now what will happen as it gets closer to it? Yeah. And because this is quite heavy compared to this, these will not really move. So to make the actual calculation easier, we'll imagine they're fixed. Now, of course, they're not really fixed. They will be pushed away as this one approaches. But just to make it easier, we can assume that it'll be fixed because it's 3 times the mass. So it'd be kind of like if you had one student pushing 3 students. Both will move, but really just the one is the one that's doing all the moving. So how close will it get? Well, what will happen to it? Describe what's going to happen to this proton. It will get closer. Describe in words, not sound effects, what's happening.
So it gets closer and then it will deflect away.
Yeah. Well, it'll stop. If we can only move in a straight line.
Okay, then it will stop and go.
And then go backwards then.
Yeah.
Yeah. So what is interesting here at this point about its energy?
Lowest.
No, because energy is conserved, so it doesn't change.
It's
Third question.
Yes.
potential energy is like
It changes from one form to another. Gotcha.
it's zero and it becomes all like kinetic energy.
Yeah, but which one is the potential zero?
Because it stops, so the kinetic will be zero.
No, you have it backwards.
So it's
Here the kinetic energy is zero because it's not moving, and here the potential energy is zero because it's free.
okay.
So that means the kinetic energy here is not zero, and that means the potential energy here is not zero. So the kinetic on the left equals the potential on the right. Now there's a sign issue here. We don't really want to have the minus in it because it's not trapped. Because as it approaches it, it's not being captured into an orbit, it's being repelled. So it's actually a positive. K, E.
That's what you were explaining yesterday. right?
Yes, exactly, yeah. 3E over or squared. And what are we looking for here? I want to know the or. So or is equal to square root.
Do we know the V?
That.
Yeah, exactly. I think we want the V.
Oh, we want the V and we know the or. Okay. So V will equal square root 6k e squared. If I bring the 2 up here, that's 6k e squared over, and then there's an m or squared. Good. So this is the answer then. So if we type in square root 6 times 8.99 times 10 to the 9 times e squared all over mass of an electron times nano, isn't that what I said, 1 nanometer?
Yes.
Which is 10 to the minus 18 then when we square it. Did Fawn say she'd be late by 15 or 50? 15.
1.4 times 10 power 10.
10 power 10. That is disturbingly big. Considering that makes it travelling faster than the speed of light.
Something 3.6 times 8.9 times 10 power 9 times e square over me times 10 power negative 18. Yes, 3.9.
You have a square root, don't you?
Yeah.
You agree? Rats, I made the numbers ridiculous then. What is it?
3.9.
Yeah.
10 power 10.
Yeah, your story checks out.
Yeah, the speed of meters per second. Wait,
That's a problem.
isn't light times
Yeah.
3 power times 8?
Yeah, this is my concern. So it's going simply 100 times faster than the speed of light. Yeah. So the problem is that obviously doesn't happen. So I made it get too close to the protons. Because, you know, if it gets 1 nanometer close to the protons, that means it has to be going initially 100 times the speed of light. We try to avoid doing that in physics. Because, as you know, when things go faster than the speed of light, they start traveling backwards in time.
Oh, really?
True, yes, true.
But I know this about space. Like if you travel faster than the speed of light.
Yeah, you travel backwards in time.
Yes, and then you see the history of the dinosaurs.
Yep, everything starts moving backwards through your point of view.
Nice.
Yeah.
There is this an old movie. This guy.
The time machine.
No, not the time machine. The guy, his father makes a watch, and then this watch makes him faster than.
Yeah. Such an old movie.
Yeah,
though.
when he clicks the button on the watch, he starts moving faster, so everything around him is slower.
You guys know this movie?
Yeah. Time stop.
I remember.
Time stop.
Time stop.
I'm gonna watch this because I like time movies.
It's
like
really nice.
1990 something.
Yeah, and then at the end of the movie, they create a chamber where.
Now stop talking.
No, I want to.
Stop talking.
Spoilers.
Spoiler alert. Spoiler alert. I'll simply watch it over the weekend.
Okay, but I'll ask you. It's not
Okay.
kind of connected.
It's really cool.
If you're like really fast, as in as a human, what will happen to your particles?
Really fast.
Yeah,
Like how fast?
I don't know.
You start feeling.
Like really fast.
Yeah.
Because he got really fast.
Yeah. And then disappeared.
No, and then he like it kind of makes sense.
Evaporated.
His what I understood from it, his particles were moving so fast that it stopped having a mass or something, so that he can walk through whatever he wants.
Not that it stopped. Yeah, it's not that he stopped having a mass. It's just
Yeah.
they move so
Functions
fast
are,
that they
yeah.
can phase through.
Yeah.
Like in the Flash.
The Flash.
The Flash does that.
I don't know how accurate that is.
Yeah, like.
But like, your electrons are that fast.
Then it's
Every electron in every atom in your body is that
I'm
fast.
blown up.
I don't know about this now.
Go watch the movie. I'll just make sure of the name.
I don't think phasing through walls is actually a real thing. Even what I mean by that is even theoretically.
Oh,
Do you know? I don't think so.
I think it's logical. Like if it happens. Because your particles they start spacing out, so they can go through stuff. I don't know.
I don't know.
clock stopper.
Clock stopper. It's a terrible name for a movie, but it sounds good anyways. All right.
It's really cool.
Yeah, it's this. Yeah, it's
Who's the actor in it?
this. Zach Gibbs.
Is this a movie of nobody?
That's his father.
No.
That's the villain. That's his father.
Wow. This
Zach
looks
Gibbs.
so 1990s.
2002.
2002?
A teenager accidentally activates a machine that enables him to speed up his body so that other people seem to be standing still.
Freeze the
Did they have
future.
like a nitrogen gun or something like that?
To freeze them up, yeah.
Damn man.
I don't have any money. Do you have any
I
money?
take it this was a movie that went straight to DVD, right?
No.
It was in the cinema?
Yeah.
Wow, weird. Okay. Continuing.
Opening weekend.